Hello students, welcome to maths class. Now in today's class, let us solve the problems on the shortest distance between two lines. Either it may be skew lines or parallel lines. So we have derived the formula for that. So we have derived that the shortest distance between the skew lines where the equations of the line L1 and L2 were vector r is equal to vector e1 plus lambda times vector b1 and vector r is equal to vector a2 plus mu times b2. So these are skew lines, then the shortest distance between them is given by b1 cross b2, vector b1 cross vector b2 dot vector a2 minus vector a1 whole divided by magnitude of vector b1 cross vector b2. Then we also derived the formula for shortest distance between parallel lines. So for the parallel lines, the equation of the lines L1 and L2 will be vector r is equal to vector a1 plus lambda times vector b, and where L2 will be vector r is equal to vector a2 plus mu times b. So here, how to identify the question whether the given lines are parallel lines or skew lines? It is if b1 and b2 are different vectors, two different vectors, then we'll take that as skew lines. If they are same vectors, then it is parallel lines. Then the formula for the parallel lines will be given by vector b cross a2 vector a2 minus vector a1 by magnitude of vector b. So let us solve the problem. So the first question, they've asked us to find the shortest distance between the lines L1 and L2 whose vector equations are given. So the vector equation is vector r is equal to I cap plus j cap plus lambda times 2I cap minus j cap plus k cap. And one more equation, equation of the line 2 is vector r is equal to 2I cap plus j cap minus k cap plus mu times 3I cap minus 5j cap plus 2k cap. So here you can see vector b1 and vector b2 are two different vectors. They are not the same. So this is for skew lines. So this equation is in the form of vector r is equal to vector a1 plus lambda times vector b1 and vector r is equal to vector a2 plus mu times vector b2. Okay, this is this form of the equation. Now from this you are able to understand what are your vectors a1, a2, b1, b2. Let us write that first. So vector a1 is nothing but I cap plus j cap and vector a2 is 2I cap plus j cap minus k cap. Next let us write what is vector b1. Vector b1 is 2I cap minus j cap plus k cap and vector b2 which is nothing but 3I cap minus 5j cap plus 2k cap. Okay. So we know the formula for the shortest distance between the two skew lines is this. According to that, let us start finding the values. So here we need to find what is b1 cross b2 and also what is vector a2 minus a1 and also magnitude of vector b1 cross vector b2. So first let us find what is vector a2 minus a1. So vector a2 minus vector a1 which is equal to what is vector a2 which is nothing but 2I cap plus j cap minus k cap minus vector a1. Vector a1 is given by I cap plus j cap. Now we should subtract these two equations. So 2I cap minus it plus this becomes minus 2I cap minus 1I cap is nothing but 1I cap. Next plus j cap here it will be plus into minus minus. So plus j cap minus j cap it is nothing but you can write it as plus 0 j cap or you can even not write. Next minus k cap, there is no k component here, so it is understood it is 0. So minus k cap minus 0 k cap, it is minus k cap. Okay, so we found what is vector a2 minus vector a1. Next, let us find what is vector b1 cross b2. So in order to find the cross product between the two vectors, we find the cross product between the two vectors by using determinant. So determinant of the first one should be written like I, j and k. Second row, the scalar components of the vector v1, and the third row is the scalar component of the vector v2. So the scalar component of the vector v1 is 2, minus 1 and 1. So 2, minus 1, 1. And the scalar component of the vector v2 is 3, minus 5 plus 2. So 3, minus 5 plus 2. Now let us solve this. This is equal to. So this is plus, minus, plus. So this is plus, minus, plus. So it is plus I into. Now neglecting the first row and the first column, neglecting this. So we should multiply minus 1 into 2. It is nothing but minus 2 minus of minus 5 into 1, which is minus 5. Okay, next what we should write? We should write minus. So minus. Next we have second term is j cap into. Now neglecting again the first row and the second column. Now the corresponding row and the column should be neglected. So next it is 2 into 2, which is 4, minus. Next it will be 3 into 1, which is 3. Okay, next we have plus. Next is third component is k cap into. Now neglecting the first row and the third column. So we get 2 into minus 5, which is minus 10, minus 3 into minus 1, which is minus 3. Okay, so simplifying this is equal to I cap into minus 2, minus into minus plus, so minus 2 plus 5, which is nothing but plus 3. Next, minus j cap into 4 minus 3, which is 1. Next, plus k cap into minus 10, minus into minus becomes plus, so minus 10 plus 3, which is minus 7. Therefore, you get v1 cross v2 as 3i cap minus 1j cap minus 7k cap. So now we already found what is a2 minus a1 and also v1 cross v2. So next step is to find what is the magnitude of v1 cross v2. So magnitude of v1 cross vector v2 is equal to root of, we already know how to find the magnitude of any vector. So root of x square plus y square plus z square. So what is the value of x here? It is 3, y is minus 1, z is minus 7. So that becomes 3 square plus minus 1 the whole square plus minus 7 the whole square. So this will be equal to root of 3 square is 9, minus 1 whole square is 1, and minus 7 whole square is 49. So 49 plus 10, it is root 59. So we now found all these values. Now let us substitute in the formula. Remember students, always you should write the formula. So D is equal to magnitude of vector v1 cross vector v2 dot vector a2 minus vector a1 by whole divided by magnitude of vector v1 cross vector v2. Okay, therefore this is equal to. Now let us start substituting it. So what is v1 cross v2? What is here? This is the vector. So vector v1 cross v2 is given by 3i cap minus j cap minus 7k cap dot vector a2 minus a1. We found that vector a2 minus a1 is I cap plus 0j cap minus k cap whole divided by magnitude of vector v1 cross v2. So the value of magnitude of vector v1 cross v2 is root 59. So this is equal to, now we need to find the dot product between the two vectors. In order to find the dot product between the two vectors, what we usually do? We multiply only the scalar components of the vector. So what I should do here? 3 into 1 Okay, I component with I component if you multiply. 3, the coefficient of I here is 3 and here it is 1. So 3 into 1 which is 3. Next j with j minus 1 into 0. Minus 1 into 0 it is 0. So we can write plus 0 or minus 0. Then minus 7 k cap into minus 1 k cap. So minus 7 into minus 1 it is plus 7 whole divided by root 59. Okay, so what will be the final answer? So 3 plus 7 which is equal to 10. Therefore, we will get it as 10 divided by root 59 is your final answer. That is the shortest distance between the two skew lines. Understood? So while solving, first step, first you should identify which is your A1 vector, A2 vector, B1 vector and B2 vector. After that, find what is vector A2 minus A1. Next step is to find what is vector B1 cross B2. Next, finding the magnitude of vector B1 cross B2. Then finally, substituting all these values in the formula and simplifying. Next problem. Here also we need to find the shortest distance between the two lines. So let us see whether these two lines are skew lines or parallel lines. So if I observe, so first and foremost the equation is given in the form of vector r is equal to vector a1 plus lambda times. Here this is the vector b1 and if you see the vector b2, they are two different vectors. So this is vector b1. And second equation is vector r is equal to vector a2 plus mu times vector b2. So from this clearly we know that it is skew lines. So here what is the first step? We can write what is vector a1. So vector a1 is equal to I cap plus 2j cap plus k cap and vector a2 is equal to 2I cap minus j cap minus k cap and vector b1 is equal to I cap minus j cap plus k cap. Vector b2 is equal to 2I cap plus j cap plus 2k cap. You can even skip this step if you can easily identify and write the vectors directly. So next step is to find what is vector a2 minus vector a1. So vector a2 minus vector a1. So vector a2 which is given by 2I cap minus j cap minus k cap minus vector a1 which is I cap plus 2j cap plus k cap. So this is equal to, now subtracting the two vectors, 2I cap minus 1I cap, that is I cap. Next, minus j cap, this becomes minus and plus minus. So minus k cap minus 2j cap minus 3j cap. Next, minus k cap plus and minus minus k cap minus k cap minus 2k cap. Okay, next finding what is vector b1 cross vector b2. So I, j, k in the first row. Next scalar component of the vector b1 which is given by 1, minus 1 and 1. So 1, minus 1, 1. Next scalar component of the vector b2 which is 2, 1 and 2. 2, 1 and 2. So here it is plus, minus, plus. So you should neglect the first row. When you consider expanding along the first row, I cap plus, I cap into. Now neglecting the first row and the first column. So we get minus 1 into 2 is minus 2. Minus 1 into 1 which is 1. Next minus. The second component is j cap into, neglecting the first row and the second column, 1 into 2 it is 2 minus 2 into 1 which is 2. Okay, next plus k cap into, now neglecting the first row and the third column, 1 into 1 which is 1 minus 2 into minus 1 which is minus 2. Therefore, this is equal to minus 2 minus 1 minus 3. So, minus 3 I cap, next 2 minus 2 0. So, plus 0 j cap, then 1 minus into minus plus. So, 1 plus 2 is 3. So, plus 3 k cap. Next, what is the next step? We need to find the magnitude of vector v1 cross vector v2. So, root of this minus 3 whole square plus 0 square plus 3 square. So, this is equal to root of 9 plus 9 which is root 18 you can write, or root 18 which is equal to 3 root 2. Okay, root 18 which is equal to 3 root 2. Next, substituting all these values in the formula, and formula is given by vector D is equal to vector V1 cross vector V2 dot vector A2 minus vector A1 whole divided by magnitude of vector V1 cross vector V2. Modulus of vector V1 cross V2 dot A2 minus A1 by magnitude of vector V1 cross V2. So this is equal to, so what is vector V1 cross V2? It is nothing but minus 3i cap plus 0j cap plus 3k cap dot, next A2 minus A1, vector A2 minus vector A1 is I cap minus 3j cap minus 2k cap whole divided by, so this is given by 3 root 2. Magnitude of vector V1 cross V2 is 3 root 2. So this is equal to, now finding the dot product. So minus 3 into 1 which is minus 3, then 0 into minus 3 it is 0, 3 into minus 2 which is minus 6 whole divided by 3 root 2 inside the modulus. So this is nothing but minus 9, minus 3 minus 6 minus 9 by 3 root 2 modulus. So this gives you 3 by root 2. So as we have written modulus, and since we are calculating what distance, it should be always positive. So 3 divided by root 2. 3, this is 3 into 3, 9. So 3 and 3 get cancelled. So 3 by root 2 is the distance between the given two lines. Next problem. So here also we need to find the shortest distance between the two lines, and here the two lines are skew lines, as V1 and V2 are two different vectors. So here vector A which is given by I cap plus 2j cap plus 3k cap, and vector A2 which is 4i cap plus 5j cap plus 6k cap, and vector V1 which is I cap minus 3j cap plus 2k cap, and vector V2 which is 2i cap plus 3j cap plus k cap. Okay, so let us find what is vector A2 minus vector A1. Vector A2 which is 4i cap plus 5j cap plus 6k cap minus vector A1 which is I cap plus 2j cap plus 3k cap. So subtracting 4 minus 1 which is 3i cap, next 5j cap minus 2j cap, so plus 3j cap plus 6k cap minus 3k cap, again it is plus 3k cap. Okay, next let us find what is vector V1 cross vector V2. So determinant of I, J, K. So in the first, second column it is the scalar components of vector V1 which is 1, minus 3 and 2. 1, minus 3, 2, and next the scalar components of the vector V2 which is 2, 3 and 1. 2, 3, 1. So neglecting, so what you should do? First you should write plus, minus, plus. So expanding along the first row. So this is equal to plus I cap into neglecting the first row and the first column. So we get minus 3 into 1, which is minus 3, minus 3 into 2, which is 6. Then minus j cap into neglecting the first row and the second column. 1 into 1, it is 1, minus 2 into 2, which is 4. Then plus k cap into, so neglecting the first row and the third column, 1 into 3, it is 3, minus 2 into minus 3, which is equal to minus 6. So this is equal to minus 3 minus 6, it is minus 9. Therefore, minus 9 I cap. 1 minus 4, which is minus 3. Minus 3 into minus j cap. So it is plus 3j cap. Next 3 in here it is minus into minus plus. So 3 plus 6, it is 9. So plus 9k cap. So magnitude of vector b1 cross vector b2 is equal to root of minus 9 the whole square plus 3 square plus 9 square, which is equal to root of 9 square 81 plus 9 plus 81, which is equal to root of 171, and root 171, which is equal to 3 root 19. Okay, now let us substitute these values in the formula. So this is equal to formula which is given by modulus of b1 cross b2 dot vector a2 minus a1 divided by magnitude of vector b1 cross vector b2. So what is vector b1 cross b2? Which is minus 9 I cap plus 3 j cap plus 9 k cap dot vector a2 minus a1, which is 3i cap plus 3j cap plus 3k cap whole divided by magnitude of vector b1 cross b2, which is 3 root 19. Now let us find the dot product between these two vectors. Minus 9 into 3, it is 27 minus 27, then 3 into 3 plus 9, then 9 plus 9 into plus 3, again it is plus 27, whole divided by 3 root 19, 3 into root 19. So minus 27 plus 27 get cancelled, so we get 9 divided by 3 root 19, therefore simplifying this we get 3 by root 19 as the shortest distance between the given two lines. Next question. So here we need to find the shortest distance between the two lines again. So here directly they have not given the equation in the form vector r is equal to vector a1 plus lambda times vector b1 and vector r is equal to vector a2 plus lambda times b2. So first we need to reduce the given equation into that form. So let us reduce, let us take up the first equation given here. So vector r is equal to 1 minus t into I cap plus t minus 2 into j cap plus 3 minus 2t into k cap. So multiply this I cap here. So it is 1 I cap, then it is t times I cap, then plus t j cap minus 2 j cap plus 3 k cap minus 2 t k cap. After that, group those terms which does not contain t. So which does not contain t is 1 I cap. Next we have minus 2 j cap. Next we have plus 3 k cap. Plus, next let us group the terms which contains t. So we have minus ti cap plus tj cap minus 2t k cap. So from these terms I can take t common. So we get 1 I cap minus 2j cap plus 3k cap plus, if I take t common, I'll get minus 1 I cap plus j cap minus 2k cap. Now, the first equation got reduced in the form of vector r is equal to vector a1 plus lambda times vector b1. Though you may not have lambda here, t or lambda is any scalar which we are going to multiply. So it can be either t, s, a, b. Usually we take excluding a, b, c, and x, y, z. We can consider the remaining alphabets. So t, it is like lambda. It is the scalar quantity which we are going to multiply. So here we have A1, which is 1 I cap minus 2 j cap plus 3 k cap, and vector B1 minus I cap plus j cap minus 2 k cap. So similarly, let us reduce the second equation in this form. So for that, we have vector R is equal to, I am going to directly multiply this. So we will get S into I plus 1 into I. Next, we have plus 2s into j minus 1 into j. Next, minus, you want to multiply this minus sign inside, minus 2s into k, then plus into minus 1 into k cap. After this, group all the terms which does not contain s. So it is 1 I cap. So these terms are those which does not contain s. 1 I cap minus 1 j cap. Next, minus 1 j cap. Next, we have the terms which contains s, that is s I cap plus 2s j cap minus 2s k cap. What you should do next? You should take s common. So vector R will be given by 1 I cap minus 1 j cap minus 1 k cap. Then taking s common, we get I cap plus 2 j cap. Next we have minus 2 k cap. So even our second equation got reduced in the form of vector R is equal to vector A2 plus mu times vector B2. So from this, we know what is our vector A1, A2, B1, B2. So vector A1, which is equal to 1 I cap minus 2 j cap plus 3 k cap, and vector A2, which is equal to 1 I cap minus 1 j cap minus 1 k cap, and vector B1, which is equal to, vector B1 is minus I cap plus j cap minus 2 k cap, and vector B2, which is equal to I cap plus 2 j cap minus 2 k cap. Okay, what is the next step to be done? We need to find what is vector A2 minus vector A1. So which is given by vector A2 is 1 I cap minus 1 j cap minus 1 k cap minus vector A1, which is 1 I cap minus 2 j cap plus 3 k cap. So this is equal to, so 1 minus 1, which is 0 I cap. Next, minus 1 j cap, minus into minus plus, so minus 1 j cap plus 2 j cap plus 1 j cap minus k cap minus 3 k cap, which will give you minus 4 k cap. Okay, next step, we need to find what is the cross product between the vectors v1 and v2. So I, j, k, so it is minus 1, 1, minus 2, then 1, 2, minus 2. So here it is plus, minus, plus. So neglecting the first row and the first column because we are expanding along the first row. So plus I cap into, so neglecting the first row and first column, 1 into minus 2, which is minus 2. Minus 2 into minus 2, which is minus 4. Then minus j cap into, neglecting the first row and the second column, minus 1 into minus 2, it is plus 2, minus 1 into minus 2, which is minus 2. Then plus k cap into, neglecting the first row and the third column, minus 1 into 2, minus 2, minus 1 into 1, which is 1. Therefore, this is equal to, so we have minus 2 plus 4. Minus 2 plus 4 is plus 2 and cap. Then 2 minus and minus plus. So 2 plus 2, 4. 4 into minus j cap minus 4 j cap. Then we have minus 2 minus 1 minus 3. Therefore minus 3 into plus k cap, which is minus 3 k cap. Next we need to find what is the magnitude of vector v1 cross v2, which is root of, we have 2 square plus minus 4 the whole square plus minus 3 square. Therefore, this is equal to root of 4 plus 16 plus 9, which is nothing but root 29. So let us substitute this in the formula. Therefore, this is equal to modulus of vector v1 cross v2 dot vector a2 minus a1 by magnitude of vector v1 cross v2. So vector v1 cross v2, which is 2I cap minus 4j cap minus 3k cap dot vector a2 minus a1 0I cap plus 1j cap minus 4k cap whole divided by root 29. Finding the dot product between these two vectors. So 2 into 0, which is 0. Next minus 4 into plus 1, which is minus 4. Minus 3 into minus 4, which is plus 12 divided by root 29. So minus 4 plus 12, which is 8 plus 8 divided by root 29 is the shortest distance between the given two skew lines. Next question, we need to find the shortest distance between the lines. Here the lines are given in Cartesian form. So first let us reduce into vector form. You can even use Cartesian formula, but we already know, we are very much familiar with vector formula. It is very convenient or very easy for you to remember this. So we can just reduce this in the vector form and solve with the same steps. So first equation is x plus 1 divided by 7, which is equal to y plus 1 divided by minus 6, which is equal to z plus 1 by 1. So first we need to reduce in the general form, Cartesian form. That is, the Cartesian form is given by x minus x1 by a1, which is equal to y minus y1 by b1, which is equal to z minus z1 by c. Okay, so here, what is the value of x1? x1 value is minus 1. And y1 value is also minus 1. And z1 value, it is also minus 1. We have already seen how to solve, how to reduce the Cartesian form into vector form. So according to that, x1 value is minus 1, y1 value is minus 1, z1 value is minus 1. a1 is 7, b1 is minus 6, c1 is 1. And what is x1, y1, z1? x1, y1, z1 are the scalar components of the vector a1. And a1, b1, c1 are the scalar components of the vector b1. Remember this? x1, y1, z1 are the scalar components of the vector a1. And a1, b1, c1 are the scalar components of the vector b1. So according to that, let us first write what is vector a1. Directly we can write. So looking at this, a1 general formula, I write it off first. x1 I cap plus y1 j cap plus z1 j cap. So this will be given by, what is the value of x1? It is minus 1, because this should be written in the form of x of x minus of minus 1. So x1 value is minus 1. So minus 1 I cap. Next y1 value, which is also minus 1 j cap. Then z1 value, which is minus 1 k cap. Next vector b1, which is equal to a1 I cap plus b1 j cap plus c1 k cap. So which is given by a1 is 7, b1 is minus 6, c1 is 1. So 7 I cap minus 6 j cap plus 1 k cap. So we know what is vector a1 and what is vector b1 from the equation number 1. Why from this we get this is the Cartesian form for the vector equation. Vector R is equal to vector A plus lambda times vector B. We derived this equation of a line passing through a point and parallel to a given vector. So when we derived, we got this as the vector form, and the x minus x1 by a1, y minus y1 by b1, and z minus z1 by c1 as its Cartesian form. There we have mentioned a, b, c. Why? Because we have considered only one line. So here we have two equations. In order to differentiate, we write it as a1, b1, c1 and a2, b2, c2. So now let us take up the second equation. The second equation is x minus 3 by 1, which is equal to y minus 5 by minus 2, which is equal to z minus 7 by 1. So this is in the form of x minus x2 by a2, because it is the second equation. We'll be writing as x2 and a2. So y minus y2 by b2 and z minus z2 by c2. So from this, can you tell me what is vector A2? Vector A2 means it is nothing but x2i cap plus y2j cap plus z2k cap. Therefore, this will be given by x2 is nothing but only 3. See here, compare and write the values. So x2 is 3i cap, y2 is plus 5j cap and z2 is plus 7k cap. Okay, next vector b2, which is given by a2i cap plus b2j cap plus c2k cap, therefore which is equal to 1i cap minus 2j cap plus 1k cap. Now we know the values of a1, b1, a2, b2. What is the next step to be done? We need to find what is vector a2 minus vector a1. Vector a2, which is given by 3i cap plus 5j cap plus 7k cap minus vector a1. Vector a1 is nothing but minus 1i cap minus 1j cap minus 1k cap. Therefore, this is equal to 3 minus it minus plus. So 3 plus 1, 4i cap. Then 5, here also minus it minus plus. So 5 plus 1 plus 6j cap. 7 plus 1 is 8k cap. Next, finding the cross product between the vectors b1 and b2 using the determinant. So first row I cap, j cap, k cap. Next, second row scalar components of the vector b1, which is 7 minus 6 and plus 1. And third row scalar component of the vector b2, which is 1 minus 2, 1. So this is plus, minus, plus, expanding along the first row. So expanding along the first row, which will be equal to plus I cap into, neglecting the first row and the first column, minus 6 into 1, minus 6, minus 2 into 1, which is minus 2. Then minus j cap into, neglecting the first row and the second column, 7 into 1, which is 7, minus 1 into 1, which is 1. Next, plus k cap. So neglecting first row and the third column, 7 into minus 2, it is minus 14, minus 1 into minus 6, which is equal to minus 6. And for this is equal to, so we have minus 6 plus 2, minus 6 plus 2, minus 4 I cap. Next, 7 minus 1, 6, therefore it will be 6 into minus j cap, it is minus 6 j cap. Next, minus 14 plus 6. So minus 14 plus 6, which is minus 8 k cap. Okay, so next we need to find the magnitude of vector v1 cross vector v2, which is root of, we have minus 4 the whole square plus minus 6 whole square plus minus 8 whole square, which is equal to root of minus 4 square 16, 6 square 36, 8 square 64, which is equal to root 116. Okay, so root 116 is nothing but 2 root 29. That is 4 times 29 is root, it is 116. Therefore, root 116 can be written as 2 root 29. So now substituting the values in the formula, which is equal to modulus of V1 cross V2. What is V1 cross V2? Which is minus 4I cap minus 6J cap minus 8K cap dot A2 minus A1, which is 4I cap plus 6J cap plus 8K cap whole divided by magnitude of V1 cross V2, which is 2 root 29. Therefore, this is equal to, so this minus 4 into 4, which is minus 16, minus 6 into 6, which is minus 36, minus 8 into 8, minus 64, divided by 2 root 29. So, if you add all this, minus 16, minus 36, minus 64, we get minus 116 divided by 2 root 29. So, since it is distance, we should take the positive value. So, 116 divided by 2 root 29, which is nothing but 58 divided by root 29. And 58 can be written as 2 times 29 divided by root 29. Okay, so here what I am going to do is, I shall write this 29 as root 29 the whole square. So, if I write this 29 as root 29 the whole square, whole divided by root 29, this 29 with one of the 29 get cancelled in the numerator. So, we get the final answer as 2 root 29. Understood? So whenever they are given in the partition form, better reduce it into the vector form and find what is vector A1, vector B1, vector A2 and vector B2, and you can simplify very easily with the formula of the vector form, that is vector B1 cross B2 dot vector A2 minus A1 by magnitude of vector B1 cross vector B2. Next problem. Here also we need to find distance between the two lines. And here, if you observe these two lines, here you can see these two vectors, that is V1 and V2 are same. Means it is understood that they are parallel lines. Now you should use the formula of parallel lines, which is given by vector B is equal to modulus of vector B cross A2 minus A1 divided by magnitude of vector B. So this equation is in the form vector R is equal to vector A1 plus lambda times vector B, and vector R is equal to vector A2 plus mu times vector B. So let us write what is vector A1 first. So vector A1 is I cap plus 2j cap minus 4k cap, and vector A2, which is equal to 3i cap plus 3j cap minus 5k cap. We know that the formula of the distance between the parallel lines, it is modulus of vector B cross vector A2 minus vector A1 by magnitude of vector B. So we know what is vector A2, what is vector A1, and also what is vector B, which is 2i cap plus 3j cap plus 6k cap. Okay, so according to the formula, let us find what are the requirements. So first we need to find what is vector A2 minus vector A1. Vector A2 minus vector A1, which is 3i cap plus 3j cap minus 5k cap minus vector A1, which is I cap plus 2j cap minus 4k cap. So which is equal to 3 minus 1, which is 2i cap. Next 3 minus 2, which is 1j cap, minus 5 plus 4, which will be equal to minus 1k cap. Next, after finding A2 minus A1, what is the next step? We already know what is B. Okay, next let us find what is B cross vector A2 minus A1. That is the cross product between the vector B and also the vector which we have found. That is vector A2 minus vector A1. We have again got a vector. So we need to find the cross product between these two vectors. So it is I cap, J cap and K cap Then in the second row, you should write the scalar component of the vector b, which is given by 2, 3, 6. 2, 3, 6. In the third row, we should write the scalar component of the vector, which is formed by vector a2 minus vector a1, which is 2, 1 and minus 1. So now expanding along the first row, so this will be equal to I cap into 3 into minus 1 minus 3 minus 1 into 6, which is equal to 6. Then minus j cap into 2 into minus 1 minus 2 minus 2 into 6, which is 12, plus k cap into 2 into 1, which is 2, minus 2 into 3, which is 6. Therefore, this is equal to minus 3 minus 6, which is minus 9, I cap. Next, minus 2 minus 12 minus 14 into minus j cap. So, plus 14 j cap. Then we have k cap, that is 2 minus 6, so minus 4 k cap. Okay, next we need to find even the magnitude for this one. Given this whole magnitude is also there, so we need to find the magnitude of this. Magnitude of vector b cross vector a2 minus vector a1, which is equal to root of minus 9 the whole square plus 14 square plus minus 4 the whole square. So this is equal to 9 square 81, 14 square 196, 4 square 16. So if you simplify this, you will get this to be as root of 293. Okay, after this, let us find what is magnitude of vector b, since we need given that. So magnitude of vector b is given by root of 2 square plus 3 square plus 6 square, which is equal to, so 2 square 4, 3 square 9, 6 square 36, which is nothing but 49 root 49, which is given by 7. Substituting this value, so b cross vector a2 minus vector a1, magnitude of vector b cross vector a2 minus vector a1 is given by root 293, 4 divided by 7. So this is nothing but the distance between the two given parallel lines. So this completes the problem on the shortest distance between the two lines, either the lines given as skew lines or the parallel lines.